Greetings mathematicians. In this video we're continuing our work with simplifying radicals, but we're working with some problems that are a bit more involved. So let's take a look at this next example. For this problem, we kind of need to work backwards a little bit. We're trying to figure out, we have a solution. We know our solution is 5 root 2. And we have part of the original problem. We know that part of our original problem is that it starts off as the square root of 10 times something. And we need to figure out what is that something. And we're trying to work backwards to figure that out. So the way we're going to approach this problem is that we're going to kind of work along one side of the equation at a time, using the same processes that we did before until we can match some things up. So remember what we did before is that we started by finding a prime factorization. So we're going to start working on the left-hand side of this equation, the square root of 10x, and we're going to make the best prime factorization that we can. So we're going to start with the square root of 10x, and we're going to take the 10 and break that into 2 times 5. Now the x, we can't really break that down because we don't really know what that breaks down into. What we do know is that once we've broken this down, that we'll have something that had a pair of 5s in it, because in our solution we have a 5 out front. And in all those problems we completed in the previous section, the previous video, we know that if we had a pair of 5s, we would have the square root of 5 times 5, and we would just get a 5 out front. That's what we have over here in our answer. So we know that this 5 needs to have a pair with it. We need to have another 5 with it. And we also know, similarly, this root 2 that's in our answer, that tells me that there has to be a 2 left over that's not part of a pair. So this 2 here is not going to be part of a pair. So that's telling me that when I go to break this up here, that I'm going to have a root 2 here, and that this x, really, if I'm thinking about it, if it has to end up giving me something like this, then this x has to be a 5. The square root of 5 times 5 giving me a 5, that tells me my x must be a 5. That's the only way I can end up with this 5 as my coefficient. So I'm kind of working through some reasoning skills to figure out what must have been plugged in for that x to end up with that coefficient of 5 out front. So my x needs to be a 5. Now here's another one for you to think about, and we'll approach it the same way. Try to think about this as, what had to happen for you to end up with your answer having a 4 out front? Well, you would have had to have had something with a 4 times 4 inside of the radical. And if you had a 3 left over, you would have had to have only 1 3. And that would have had to been what this gave you in the prime factorization. This would have had to give you the 3 times x would have had to been the same as this. These would have had to been the same thing. And then if you go and you look and you say, well, I've got this 3 accounted for, but this x, that has to be this 4 times 4. And 4 times 4 is 16. So that's telling me that my x must be the 16. And then you can check your answer on these by, if you were to go back to the beginning, plug in what you think your answer is, and try to simplify it, and then see if you get this answer over here. So like if I were to take the 3 times 16, and I were to do a prime factorization of that, and then I were to do groups of 2, I do end up getting that same answer that they wanted me to get at the beginning. So it'd be one way for you to check your work, see what you think the answer is, kind of trying to reason through it, and then try plugging it in for X and see if it works out to get the answer that you wanted to get here in the beginning. All right, moving on here, we have another property. So far we've just been working with the product property for radicals. And now we're looking at the quotient property for radicals. And this one says that if we have a quotient or a division problem or a fraction of a radical, we can break it up into two different radicals inside of a fraction. So sometimes this is easier to understand with an example. So if we look at this example here where we have the square root of the fraction 9/25, this property says that I can break this into the square root of 9 over the square root of 25, and that's the same thing. Now where this comes in handy is that the square root of 9, well, that's just 3. I'm asking myself what number times itself equals 9, 3 times 3 equals 9. Square root of 25, that's just 5. So the square root of 9/25 is 3/5. So what we've been doing so far is we've been simplifying radicals, and we talked a little bit about this first kind of rule, I guess you could call it, for simplifying. And we said that the first thing we need to do is we need to check to make sure that there are no perfect squares other than 1 that are factors of the radicand, the number inside of the square root. And the example that we had given at that point in time was the 8. And we said 8 is not simplified here, square root of 8, because I could simplify that into the square root of 2 times 2 times 2, which has a pair, and then that would be the square root of 2 times 2 times the square root of 2, and that would be 2 root 2. Now with our new quotient property, the square root of 5/16 is not simplified because it's not okay to have fractions inside of the radicand. That's not simplest form. So I would simplify this. Possibly, one thing I could try would be to break this up into the square root of the numerator over the square root of the denominator. In this case, the square root of 5 doesn't simplify. It doesn't have a nice square root like the problem we did a moment ago where we had the square root of 9 in the numerator and we simplified that just to 3. 5 also doesn't have a prime factorization. I can't break that down any further, like where the 8, I broke it into 2 times 2 times 2. So it's just going to stay root 5. Square root of 16, that is 4. So if I wanted to simplify the square root of 5/16, that becomes root 5 over 4. And then lastly, I can't have a square root in the denominator. Sometimes if you see a square root in the denominator, it's just going to have a nice square root. So the square root of 4 is just 2. There are times when that doesn't happen. It doesn't just work out nicely, like maybe if you had a square root of 5 in the denominator, you can't take the square root of 5. That's a little bit beyond the scope of this course. That's something you'll learn how to handle in Algebra 2. So we'll look at that a little bit later. For now, just know that typically it's going to work out just nicely. You're going to have something like the square root of 4 becomes a 2. Square root of 36 becomes a 6. So be looking for things like that for your denominator. Again, we're going to stop here for now, and in the next video we'll do some more examples. See you later.